Yeah, so thanks for the introduction, Greg. I'm Cole Bollig. I will be presenting on DAGMan. More specific is intermediate DAGMan. As Christina mentioned in her multiplex of talks earlier, we have a lot of old data or presentations on kind of this introductory stuff. But that doesn't mean you can't learn something from this presentation if you don't know anything about DAGMan. But just to begin with, here's some introductory material, past presentations from Condor Weeks. I know Christina recommended maybe not going back too far, but I have some 2014 presentations in there. DAGMan hasn't changed too much, I feel like, but we've added a lot of cool things, fixed some bugs. I also put in the links for documentation. You notice there's a link and then an old link. I kind of had this predicament, as Christina mentioned earlier. We're updating our documentation. Currently, the DAGMan documentations is one monolithic page hidden under user manual. We decided to make that more first class and break it up into easier digestible bits. So currently the old link will work. The not old link will be broken, but once 10.7 gets released, that will be switched. That being said, let's do a quick refresher. DAGMan is a directed acyclic graph manager. That is a mouthful. Directed acyclic graph, or DAG for short, that is a concept that is known outside of the HT sphere. It's comprised of nodes and edges. Node has an edge leading to another node, and that creates the directedness. We don't want that secondary node to loop back to the first node, acyclic, and we make this graph of dependencies. This is really nice for DAGMan, as DAGMan is the manager of these DAGs, for having workflows for you. So let's say you need one job to run before two other jobs because the first job's output is key input for the second job's. Here's a very basic example of a DAG that we have. So we have a DAG file. This is a diamond DAG. On the left, on the left is the DAG file, and then the visualized DAG is on the right. Some important things to note: when you submit a DAG to HT Condor with Condor submit DAG, the HT Condor actually creates a scheduler universe job for the DAGMan process. This runs on the AP through the schedule. It's in the queue. You can see it. And this is basically acting on your behalf to submit your jobs, make sure everything's going normal, freaking out if things are going wrong, like we do. We also produce a lot of files. These are the base files that DAGMan produces. If you really want more, we can give you more. There's ways to do that. I won't be going into those details today, but if you're interested, hit me up. There's some interesting stuff you can do. I kind of broke these into two categories. On the bottom is the DAGMan job proper files. As I mentioned, HT Condor actually submits a scheduler universe job. We refer to that as the DAGMan job proper. So it has its own submit file, its own log file, error, output. Those generally aren't used too much, but they're nice to look into. The top files, though, the informational DAG files, is very nice. So the DAGMan.out file, that'll have a bunch of debugging and error information. It can also be a lot of information, and you can easily miss information in that file. The nodes.log is, as TJ mentioned earlier, kind of this aggregate log file for all the jobs. This is the heart of DAGMan. We actually read that file to understand what's going on with your jobs. And the last one is a metrics file. This is neat. We output this at the end of a DAG's life, whether we fail or we succeed successfully. And just a bunch of general information about what's going on. It's in JSON format. You can do some parsing. As I said, the DAGMan job proper runs in the queue. It has its own class add. And with this class add, there's a bunch of information inside of it. I don't know if many of you know this. There's a bunch of information about node statuses. How many have submitted, completed successfully, how many have failed, how many are running proscripts, prescripts, how many have been submitted, how many are waiting to be submitted because their parents are done, how many are just waiting for their parents to finish. There's also this new new status called futile. It took a while for us to come up with that name, but a futile status is essentially, I'm a node and one of my ancestors has failed. I will never run. I'll never get the opportunity to run because we have this dependency graph. In the diamond DAG example, A goes to B and C. If A fails, we're not going to run B and C. The DAG has failed at the first node, so all the other nodes would be futile. It doesn't have to be your direct parents. It could be your node's parents, you know. And then, yeah, the final one is just the total number of nodes. It's kind of nice to know what's going on in your DAG. There's also a bunch of information in this class ad about the number of jobs, because a node could have more than one job. While it's more ideal for us to only have one job per node, you could have multiple job processes, as Christina kind of showed with modularizing a submit file to submit multiple. This holds information about the number I've submitted, what's idle, what's held, what's currently running, and the number of jobs I've completed successfully. Finally, there's a couple other neat little bits and bobs. In recovery mode, we have this restart setting where if your DAG blows up for extremely bad reasons and there's no rescue file, we can read the notes out log to try and remember where the heck we were. And that's called recovery mode. There's also a DAG status. It's a bit weak. We got two options. It's either okay or we're aborting for a specific reason. But all of these attributes you can easily find by running conda q. Sadly, the -l option and grepping for it. It might be nice if we add a specific flag to get this information, but that's a future thing. Now that we're here, what about rerunning a DAG? A DAG basically is a job, has two outcomes. Hopefully it succeeds. Hopefully it doesn't fail. But those are kind of the two ends of the spectrum. There might be some in-betweens, who knows? When we fail, we produce a rescue file. This is a neat little file that records how much progress we've gone through the DAG and successfully completed. And hopefully we can fix what's needed and then resubmit. And it'll skip over all of those nodes that we have successfully completed before. But what if you want to rerun a DAG that has succeeded successfully? We don't need to rerun the entire DAG. That's a bit extensive if you want to just rerun a specific section of your DAG, but you have to rerun the whole thing. You know, we got a couple things to help with this. The first one is data flow jobs. A key thing to know here is this is technically not a DAGMan specific feature. This is a submit command. This goes in your job submit file. It's skip if data flow equals true. We have a couple states that basically determine if a job is a data flow job. If the output files exist and they're newer than your input files, it's a data flow job. We don't need to rerun this. The execute file is newer than the input files. Apparently it's a data flow job and we can skip this. And then if the standard input is newer than the input files, it's also a data flow job. This is currently what we have, but this is useful because, like I said, in this case where if we have this large DAG, but maybe we change some input files way over here on the side node that starts halfway through the DAG, we don't want to run the first 100 nodes that have already run. Sadly, they will sort of run, but they'll just start up and realize, I have all my inputs, we're all good here. I'm just going to exit successfully and we can carry on with our life. A new feature, however, that we recently added in 10.5 is the save point files. Save DAG progress. The concept behind this was, what if we had video game saves for DAG? You know, nice little checkpoints. Oh, I shouldn't use checkpoints. That's an overloaded term. Nice little spots where we can save the progress, sort of like the rescue file. But you get to specify where it is. So in this example, I have a sample DAG file. These are the 4 different possibilities for declaring the save point file. And in here, we have this complex workflow. I kind of simplified it. So we have this very complex setup state. And we save, and we do a simulation, and we save again, and we do a different simulation. Save, analysis part 1, save again, and analysis part 2. And what's nice about this is if we want to restart the DAG, let's say the setup's fine, but everything else was garbage. We can restart from say point 1 and just do all this, the simulations and analysis. Maybe analysis part 2 went completely awry, but everything else is fine. We could restart from say point 4. So very nice to make this kind of linear flow of only restarting what you need to restart. This is a new feature. The question is, where do these files get written? If you give us a path, we will use that path. You tell us where to write it, we'll write it. We'll attempt to write there. If you don't have file permissions, give us a better path. If you give us a file name, we'll write it as a file name. Otherwise, if you just say, I want a save point file, we'll write that in this new subdirectory called save files. This will be in your DAG directory for all those plethora of files that we discussed earlier on. This will be written as the node name, the DAG file that it's from .save. It's pretty simple. And then to reload a save file is pretty simple. You do condor submit DAG dash load save, the save file, and your DAG. Simple as that. Once again, in this case, we respect the paths you give. So if you tell me my save file is here, we'll check there, we'll read it, all is good. If you just give us the name of a file, we'll expect it to be in the save files subdirectory. Oh, node. A point that I totally blanked and skipped on earlier in the refresher is a job is a core piece of the node. So when you declare a job, that becomes the central part of a node. But that's not the only part of a node. We have this concept of scripts. A pre and a postscript make up this node structure. And this is important to know because each of these parts in the structure can fail. And if they fail, that helps determine whether or not the node as a whole has failed or succeeded. Scripts are very useful for doing tasks at certain points in the DAG's life. A pre-script will run before the job is submitted to the sched. A postscript runs once the entire job as a whole is done and we want to do some post-analysis and stuff. And there's this other one called hold scripts. Whenever one of the jobs in the node goes on hold, we run this. The key thing to know is all scripts run on the access point, not the execution point. You want to use scripts to do kind of tasks that aren't really computational heavy, that would just kind of bog up the system. So for pre-scripts, maybe you just want to verify all of your inputs are a certain size because you expect all of your inputs to be at least 10 megabytes. So in this case, we got our script that runs before job A. If all of our input files are if one of our input files is less than 10 megabytes, we failed. We expected at least 10 megabytes of data. No point in carrying on. But if everything's A-okay, pre-script completes, the node job gets submitted and we carry on with our life. Another sort of example is you could use a pre-script to manipulate input files. You can move them, condense stuff, rename stuff. I feel like this is less commonly needed as we have this plethora of submit commands that allow you to like rename files and put them in specific places now, but it may still be useful. On the other end, postscripts. A neat little thing you can do with postscripts is you can create a loop. So in this example I have set up, I have script C as this nice little loop.shell script. So if the node succeeds successfully, as long as our retry is below the number the number of times we want to loop, then we just exit 1. This creates the node being a failure, and then retry kicks in and says, we failed, and it tries again. And then we get back, and we do that, and we keep doing that, and then finally, once retry has hit 4 times, we're like, we're done. Exit 0, the node is successful as a whole, and we carry on with the DAG. I did also put in this little special thing, so if the job doesn't exit successfully, we get a failure, then we just exit 2, and retry sees that with the unless exit and says, we got a failure, we're not going to retry, we're just going to exit here. This is nice because this also applies to subdags. We'll get into that later, but that allows you to loop an entire sub workflow as opposed to just one node, which can be useful. Couple other examples of using postscripts, just like verifying your input. Maybe you want to verify your output. Maybe you're expecting 10 files with these exact names. If only 9 of them exist, do we want to carry on? Another thing that people have used postscripts for is you can fake a node success. Maybe you have a multi-process job and it gets submitted and it does a bunch of randomization stuff, and maybe the randomizer hates you for some reason, and that one time out of 100 it fails because some bad event, but you're fine with that. We can take some variables and you can sit there and be like, ah, yes, we got this one odd specific failure that I'm fine with. That's cool. I'll just exit 0 with my postscript and the node will be successful and we'll carry on with our lives. A last thing is you can use postscripts or prescripts in that matter to generate files that need to be used by DAG. The key thing with DAGMan is all the nodes kind of need to be there at submit time, but the files don't necessarily need to. This is when you submit the DAG, when I say that. The files need to be ready the moment we go to submit or do that action. So when we want to run a prescript, we expect that script to exist. But before that, we don't care. That might be 100 nodes away. We don't care if it exists yet. A really cool thing you can do with this is actually create sub-DAG workflows on the fly because you don't know how many jobs you actually need to run. And the last example I have here is a hold script. Maybe when my job goes on hold, I just get a text message. Like I said, these aren't part of the node structure. They're best effort. If they fail, cool, whatever, but it'd be nice. This does have risks, especially in this case. So I use this nifty little keyword, all nodes. So this hold script applies to every single node in the DAG. But this runs into a risk of if all the jobs go on hold, I get 4 text messages. But what if they're all multi-proc jobs? What if each one of those nodes has 100 jobs for some reason and they all go on hold? That's 400 text messages. That's a lot. Now that we're kind of done going over what a node is, the pre and postscripts, we have some special node types. These are their own sort of category. They have their various uses. First one is a provisioner node. These are good for setting up unique resources that you need for your DAG to run. They always start before your DAG begins. We guarantee that. The other confusing thing about these is DAGMan doesn't manage it. We just submit it. The job itself has to determine when it needs to shut down because it has to deprovision resources, assumably. You can also only have one provisioner node. So for my example, maybe your complex DAG needs this super crazy quantum computing with lots of GPUs. So we create a VM up in the cloud, and that connects back to your pool's collector. Then you have those resources available for your DAG jobs. Another type of node that's sort of similar but different is the service node. This is a request by LIGO, I think. James mentioned this yesterday. These are kind of referred to as sidecar nodes. These are managed by DAGMan. They run on the side. They don't have dependencies, but they're good for running tasks. They also run at the beginning of a node. At the beginning of the DAG's lifetime, but they're not guaranteed to run before the other nodes like provisioner. They're also kind of best effort. So if one of their submissions fail, DAGMan will be like, that's all right, and we'll carry on. But it is managed, so it's submitted and removed at the end by DAGMan. Sadly, James wasn't able to really go into the depth of what he was doing with service nodes in his example, but he was actually setting up service nodes to run on the side and wait for DAG jobs to start running and then test SSH to jobs then. That's pretty cool to think about how he's doing that. But in my example, we're just having our DAG node called monitor. And that just running on the AP, it's local universe, let's say, and it's just reading our nodes.log file. That has all the job events that are going on, sending that information up to a Flask app, and that's doing of all its neat little pieces and organization, all to create a nice little web page that shows you the progress of your DAG, so you know what's going on. The final node, ironically enough, is the final node. This is a node that always runs at the end of a day, whether we are successful or we failed. This is really good for cleanup of various outputs or checking stuff from failed nodes or just making sure the overall DAG went well. Once again, like the provisioner node, there can only be one. Makes a bit more sense for the final node, because if you had 10 final nodes, which one's the final node? A bit confusing. But here's our example of the diamond DAG in our end node. So in this case, if D ends successfully, given our dependencies, that's the last job in the DAG, we have finished our DAG successfully, the end node will run. If any of those nodes fail for some reason, the DAG starts aborting and we still run our final node. Very nice. Now we get into a bit more complexity. What if you want to use a workflow inside of a workflow? There's reasons for this. The first kind of example of using this is splices. These are nice. So if you have a DAG file and you want to splice it into your other DAG file, all those nodes get added in. So here we have splice X. And in the simple sample DAG there, you see we just have job A, splice X, in a simple line parent dependency. But what that happens is once we get all the splice nodes in there, we actually have this X in the middle. And the dependencies will go A to the first two parentless nodes, and then go through its DAG progress, and then its childless nodes will go straight to C. This is really good for reusability. Maybe you have a like micro workflow that you need to do 50 times in a DAG rather than writing 50 nodes 50 times in the same DAG. You could make one DAG file and splice that in at those 50 points. This also has less strain on the AP compared to the sibling option of a sub-DAG external. We'll go into reasons in the next slide for why. There are some shortcomings for this because the nodes are spliced in. We can't run pre or post scripts on a splice. There's no true begin or end of the workflow, and the retry command also doesn't apply. There are some hackery things you could do. You could put a node afterwards that runs a postscript for your splice. But yeah, this would be handy for, like I said, maybe you have a simulation, but you have 80 different input nodes for that, rather than writing the simulation 80 times. The other option for running a workflow is a sub-DAG external. This is neat because to the parent DAG, that's the DAG that this DAG is declared in, it's just a node. So this DAG, it submits it, runs conjure submit DAG, and this DAG runs separate. This sub-DAG has its own DAGMan job proper, has all of its own files, it does its own process, it's in the queue itself, and it's just being managed elsewhere, also kind of right here. That's kind of key. If you did like a condor remove, that would tell the node to say, hey, run condor remove on the sub-DAG, and the sub-DAG would move all of its nodes. But because it has this concept of being a node to the parent DAG, we can do things like add a retry, have a pre and a postscript for the entire workflow. This comes in handy. As we said, you could loop nodes. What if that node was an entire workflow? So maybe you have this simulation that needs to run 50 times on the same set of data that produces different output. We can use a retry. Simple as that. Another neat thing is because it's considered a node, the DAG file doesn't have to exist at submit time, at conjure DAG submit time of the parent. So we can make that on the fly. I actually helped a user at LIGO who came to me with this problem. He's like, I have this DAG. It produces a random number of DAGs, and I need to run those DAGs. And I was like, wow, that's fun. Here's an example diagram of how we can do this. So we have this first node, and that creates scripts that we need to run, and the submit file that maybe creates the DAGs. And that submit file, like I said, creates a number of DAGs. We don't know how many we need until we're actually running DAGMan, and we're processing that data. Then we use a PostScript, and that writes all of those newly found DAGs into this subdag that we pre-declared. Do note in this subdag, I use subdag externals here. I feel like splices would have actually been better because, like I said, that's less strain. Because if this example produces 500 DAGs, and then we have all of them being put in as subdags, and they all run at once, all of a sudden, at a single time, one user has 502 DAG processes in the queue, not to mention all their jobs. And these run on the AP, which is the biggest kind of stress factors. They're not running on an EP being managed by some other resource. They're on the AP causing strain and stress. Some other little bits and bobs that are kind of cool. I couldn't really find a category to put them in. If you want to reuse one submit description, so a submit file that's modular, we can use the vars command. So this way you can declare, in our diamond DAG case, we have B and C, which are the middle nodes. They use the same submit file, but we just pass the macro or the variable country, and this will pass that modularity down. We can use that in the submit file there, and we're passing USA to my script for node B. On a low scale like this, that's only 2 nodes, but maybe you have 100 nodes that run similarly. Rather than writing 100 unique submit files to then run, you could write one and have all these var lines that pass the necessary information. You can also use this to pass my.syntax information that, if you don't know, will inject or create a class add attribute that will go into that job's class add. It does come with a couple special attributes. Job, that'll be the node name. You can pass that down to your jobs. The retry, if you're using the retry feature, the number of retries that we're on. And a kind of new thing that we added is this prepend and append concept for vars lines. This allows the macros to be digested before, to be put in before we digest the submit file or after the submit file. This is good for conditionals. So if in your submit file you have, if this is defined, do this, otherwise do this. That way we can pass down and there's a bit more extensibility involved. Another quick thing, dot files. These are good for visualizing DAGs. Pretty simple to add. There's a lot more options you can do with this, but the basic one is DAG dot, or the dot command. And that's just produce a file, and then you can run it through this command, and you can get a nice image. So using a lot of the stuff that I kind of, examples I used earlier, we have our provisioner node here, we have our final node, and then just this complex, semi-complex DAG workflow. Another quick point, since I'm kind of technically out of time, you can do custom configuration and add priorities for nodes. Custom configuration is nice because you can, it's per DAGMan process. There's a couple of highlighted configuration knobs that I have put. If you want your DAG to submit depth first as opposed to the normal breadth first for some reason, we can do that. There's also this neat new option, DAGMan node record info, that automatically creates a class add attribute for the retry number. And yeah, node priorities just means when we go to submit nodes that are ready concurrently, we submit the higher priority nodes before the others. And I'll skip the last one, sorry.